In this video, we are going to understand the effects of heat on a body. For example, if we impart some heat on a body, what will be the effect on that body? So, the first effect that we see when heat is given to any body, here I am only talking about given to any body, it may be heat is taken out of any body, that also can be into consideration. But for your better understanding, I am just taking into concept that we are giving heat to a body. So on heating a body, we generally see that the temperature of the body increases. Now, if I ask, why does the temperature of the body increase? Why does it increase? Why it does not decrease? So in answer to this question, we must all understand that whenever we are giving heat energy to a substance, we know that heat is a form of energy. So an energy can never be created nor be destroyed. So if we are giving heat, then what is happening to that heat? Where does it go? We do not see it, but that doesn't mean that the heat is getting destroyed. No, energy can never be created nor be destroyed. So where is that heat going? Actually, the heat energy that is being imparted by us on the body is being used up in increasing the kinetic energy of the intermolecules of the substance. That means when I am giving some heat, the kinetic energy of the molecules of the substance increases, and because of the increase in the kinetic energy of the molecules of the substance, they start moving quite randomly and vigorously. Because of this random and vigorous motion, they collide with each other while moving within their boundaries. Because of this collision, there is an intermolecular friction between them, and this friction actually is the main cause to impart an internal heat and increase the temperature of the body. Now we want to study about another effect of heat being imparted on a body, and this we generally see in our physical surroundings, that whenever we heat a substance, there is a change in state. For example, take out ice from the refrigerator, and when we heat that ice, it turns into water, and water is being heated again, it turns into vapor. So what is the internal molecular changes that are involved when ice turns into water and water turns into vapor? So to understand this concept, first we must know that every molecules are binded together by certain intermolecular force of attraction, because of which they can move across each other or they can vibrate among each other, but they cannot overcome the intermolecular force of attraction and move apart. So whenever we are heating a substance, we know that on heating any substance, the intermolecular kinetic energy increases. Because of the increase in the kinetic energy, the molecule starts moving randomly and vigorously with greater speed. And if you still keep on imparting heat to that substance or to that body, the kinetic energy further increases and the molecular motion increases to such an extent the intermolecular force of attraction between them decreases as the distance between two molecules keeps increasing. We should know that intermolecular force of attraction decreases when the distance between two objects increases. I mean to say that when the distance between two particles increases, the intermolecular force of attraction decreases. And on imparting heat again and again and again, the intermolecular force of attraction decreases to such an extent that they are unable to bind the two particles together, and both the particles break free the intermolecular force of attraction and they move apart, thereby changing its state. Hence we can say that on heating a substance, its state changes, that is solid changes into liquid or liquid changes into gas. The reverse is also true. On cooling a substance, gas changes into liquid and even liquid changes into water. So if you want to conclude this topic, we can say that when we heat a substance, its kinetic energy increases. Because of the increase in kinetic energy, they start moving randomly and vigorously with greater speed. Due to this random and vigorous motion, the intermolecular spacing between the objects or the molecules increases. As the intermolecular spacing between the molecules increases, the intermolecular force of attraction between them decreases. As the intermolecular force of attraction between them decreases, the forces which come into effect to hold the two molecules or bind the two molecules together becomes less. The molecules can break free and move apart, thereby changing its state. Another effect of heat on a body is the change in its size. That means the size may increase or the size may decrease. That means a body may expand or it may contract. So how does it take place and why does it take place? So let us understand it in detail. Whenever we heat any substance, let me say I have taken a piece of iron rod and I am heating it. On hitting the piece of iron rod, the molecules of the iron gain kinetic energy. Because of the increase in the kinetic energy, they start moving randomly and vigorously in all possible directions with greater speed. So as they move quite randomly and vigorously in all possible directions with greater speed and increased energy, they exert some force on the geometric boundaries of the object. So when a force is being exerted due to the motion of the molecules on the geometric boundaries of the object, there must be some work done, and the work is being done by increasing the size of the object to a certain amount. Though it may be very negligible, but still the size of the object increases. This phenomenon is known as thermal expansion. So on heating an object, its size increases. This phenomenon is known as thermal expansion. Now thinking of it, I guess girls may be very happy. They may think that if you purchase a small piece of gold from a shop and keep on hitting it, it may increase its length gradually and they may become richer day by day and day by day. But that is not true. There are certain factors on which thermal expansion depend on, and how much will it expand? There are many factors. We will discuss about it in our further learning concepts.